Hello, everybody. I'd like to talk today about random. There are many places when we're doing algorithms where we need to be able to generate a random number. For example, if you were going to play a game and needed to roll a die, you'd have to have a random number. If you were going to shuffle a deck of cards, you'd probably need a random number. In business, if you were to look at the stock market and pick a portfolio at random and see how it did against portfolios picked not at random, you would use a random number. So many things in the world, weather, for example, could be modeled as pick a random number and then go by some probability. So we need a way to to generate a sequence of numbers that are random. The problem is computers aren't supposed to do anything random. So we create a sequence of pseudo-random numbers. The pseudo-random numbers, if we're careful how we do it, produce a sequence that passes most random tests. It does about as well as random numbers. But it's actually a not random program. It produces, if you know where you start, you can predict all the random numbers you're going to get. Don't try this in any games of chance. We need to do this. We start with a seed. This is an initial number in our sequence. One way to get it is to use the time, the current time. The computers gets current time down to way past seconds. At least, I think, may go to nanoseconds. So the chances that these numbers are going to be the same each time we run the program are rather weak. So this way, every time the program runs, we get a different set of numbers. Now to do this, we need a function called sran. Sran just plain generates a number. We don't even have to give the number it generates a name. We put in the parentheses the variable time null, which is generated by the system's clock. The null is there because it needs that. So we're looking at two new things. The line looks at is sran time null. This is done once. This line starts a random number generator. That's all it does. We don't see where it starts. We don't need to. It just starts it. Now, when we want a random number, say we want to call it roll, just to give it a name. We write roll equal rand. Now that might not work the way you want it to. We're going to see in a minute. I'm going to try it and we'll see what happens. We also need a new set of include files. I can never remember them. I always have to look them up. So I'm going to go over here and find them. Here's the program. It's these three files right here. These three lines. So let me copy those over to here. We need the lines. That's kind of small, isn't it? That is standard I/O, standard library, and time. This one is not necessary for getting the random. RAN itself and SRAN are functions in the standard library. The only thing we need from standard I/O is the null. And from time, we need the function time. I got this off a place in the web where it carefully told me those things. It's the standard way to do things. So let's see what happens when we try it. Here's a program. What I have in the program is I'm opening an output file and I'm printing out row. I'm getting row. You'll notice that I have SRAN first, outside all the loops, and then I have a variable called roll that I'm going to get here. Now I'm going to try something. I'm going to see what happens if I do just what I told you before. RAN and nothing else. And then I'm going to see out RAN, see out roll, indel. Now we're going to get a few of those. I'm not going to worry about the rest of it yet. Let's just leave that alone. I'm only concerned with the lines down to 19. So I'll run them for you and see what happens. Well, there's my numbers. They look kind of strange. They certainly don't look like numbers 0 to 6 or 1 to 6. What it is that this RAN is picking a number within a certain range. The range, from the looks of it, is like 6-digit numbers, 5-digit numbers. I thought it was higher than that, but that's reasonable. We don't really need to know what the range is for what we're going to do. So those don't look pretty good. Those don't look that good. So let me just do it like this. Control C. We get numbers. A number sequence starting, for example, Now this isn't always going to happen the same as the one I just got. A second run would give different numbers. So let's think of something here. I don't want those numbers. I want to bring them down to something more reasonable. Let's suppose I want values between 1 and 6. Now you'll notice there are 6 values there. What do we have that would give us 6 numbers? We're getting RAN. It's an integer number. Is there any operation we could put on that to get us 6 possible answers? Well, we've been using it a few times for many different things. If we divide by 6 and take the remainder will be 0, 1, 2, 3, 4, or 5. There are 6 numbers there. So RAN mod 6 is a number between 0 and 5. So now if I go back to here, and instead of printing that, I print %6. Now let's see what the numbers look like. Well, that's a lot better. We're getting much better numbers. So we get numbers, oops, pardon me, I have to find it. There it is. We get numbers starting as Control V. Well, that's still not what I wanted. I wanted numbers that might make a die roll. So I would like to get numbers between 1 and 6. Well, that's pretty easy. You have numbers between 0 and 5. Guess what you can do to get them between 1 and 6? You just have to shift them over 1. So add 1 to get numbers between 1 and 6. So we use RAN mod 6 plus 1. And if we try that back here, and run it, well, now you see we're getting the right numbers. So we get a sequence starting with these numbers here. And that's exactly what we would want. That die looks kind of loaded, but I don't think it is. So this can be done for anything. Now what I'm going to try is there's a game called, I think it's Rock, Paper, scissors. Two people each put their hand in a certain way. I think this is scissors, this is rock, and that's paper. And they hide their hand behind it, and they bring them out simultaneously. And two players each choose one of these three. And then the rule is that paper covers rock, which means paper wins. Rock breaks scissors. So rock wins. And scissors cut paper. So scissors win. Of course, that would mean paper wins and rock loses. And down here, and scissors loses. And down here, and paper loses. If the contestants pick the same item, we have a tie. So what I would like to do is see if we could play this kind of game somehow. And what I decided is I'd like to play the human versus the computer. So what I'd like to do is I'd like to have the computer generate rocks, paper, scissors, whichever. And I'd like to play for, say, 100 rounds and see what happens. Of course, most humans wouldn't last 100 rounds, but the computer's different. So I just wrote a program here that will generate a number between 1 and 3. Because I have 3 choices: rock, scissors, and paper. And what I did was I said, I'm going to create a file. And the file is going to have, if I roll a 1, I'll put rock out there. If I roll a 2, I'll put scissors on the file. If I roll a 3, which is the only thing left, I'll put paper on the file. And that's it. Very simple program. Remember we talked about output files just recently. I've already run it, so I'll just go and get the results. So here's the file. I'm in Notepad, so I will open the file. And I believe yes, RPS guesses. And there you see it. Now it will be different if I run it again. I hope. All right, that's my file. What I'm going to have you do for homework is to play against the computer. I'll write up that homework in a while. And what I want you to do is I want you to basically count the number of wins, losses, and ties. Now, I have to be careful here because I have the program written. I don't want you to see it all. But what I'm going to do is hide most of it. There. And now I'm going to run it, and this is my version of it, and see what I get. And what I'm writing is wins, ties, and losses. So for example, look at this last one. Paper loses. So the losers go up 1. The first one is my choice. The last one is the computer's choice. Rock, paper. That was another loss for me. Rock, rock. That was a tie. You notice it went up 1. Paper, paper. That was another tie. I had a few of those. Where did I win? I know I must have won somewhere. Scissors, paper. I won. So I went from 23 to 24. So that's what I want you to output. You could do a little better than I did. Put a space in there. Maybe even identify them. I was just doing it quick and dirty to see what happened. So what do I want you to take from this? You have to learn how to use random. Random is a major thing that we use in many algorithms. It's not hard. It's just you have to somehow keep track of it, have an example so you can use it. We're leading up to functions very shortly. That's the next topic, I believe. And I want to point out to you that sran is a function. Time is a function. Ran is a function. All of these you recognize as functions because of the 2 parentheses after them. Whenever you see parents either empty or with something in them, like now or time now, that means that whatever's before that is a function, and we're passing it arguments. This is no different from what you have in Python. Although Python, I believe, allows you to have function names with no parentheses at all, if I remember correctly. But we will, within a few days, be talking about functions in C++. So here's some examples of them. You've already had a few others. Square root was a function. Set W, set precision. These were all functions. And fortunately, they've all been written for us. So we don't have to spend all our time figuring out how to do them. Well, that's it for now. I'll post this, and I'm also going to try to get you a homework at the same time.